how to represent rate or types of representation of rates. Types of representation of rates. Up to now, we discussed about rates only, how to calculate the rate. And now, how to represent the rate. By 3 ways, we can represent the rate. One is average rate. Second one is instantaneous rate. Instantaneous rate. Third one is initial rate. One is average rate, second one is instantaneous rate, and third one is initial rate. So, in any reaction, after some time, the concentration of reactant decreases and product increases, obviously. So, if we represent the same thing on a particular graph, when we study about reactants, if we represent the same thing in a graph here, and this is with respect to time, and this is with respect to concentration. If you take any graph with respect to concentration and temperature, what happens? This is at T0. At T0, the concentration of reactant is A0, let it be. And the concentration of reactants going to decrease as time goes on. At the starting, concentration time is 0, concentration is A0. Then after time T1, the concentration will be, let's take this one as C1. After some time, let's take the some time as T1, then the concentration will be C1. And after T2, concentration is C2. So at T0, concentration is A0. At T1, concentration is C1. At T2, concentration is C2. So by looking at these ones, what we understood? Concentration of C1 is more than concentration of C2. C1 concentration is more than concentration of C2. So if we want to calculate concentration, rate of concentration means delta C by delta T. Change in concentration with respect to time we are calculating. So what do we mean by delta C? C2 minus C1 by T2 minus T1. Final concentration is C2, initial concentration is C1. So obviously change means C2 minus C1. Then initial final time is T2 and initial time is T1. So T2 minus T1. As this concentration is disappearing or decreasing, it should be minus of this thing. And the average rate of consumption of a reactant in finite time, in a fixed time. Moderate speed reactions, examples are, so minus delta C by delta T is equal to minus of C2 minus C1 by T2 minus T1. This is in case of reactants. If we consider the same thing in case of products, then let's take the same graph, concentration with respect to time T0. At time 0, no product will be present. So after time goes on, the concentration of product goes on increasing. So as product formation will be there, so concentration of product is also going to increase. So after T1, let's take the concentration as C1. And after some time, T2, let's take the concentration as C2. So obviously C2 is greater than C1. So as time goes on, the concentration of product increases. So C2 is greater than C1. Then what about the rate of change of concentration? C2 minus C1 by T2 minus T1. No need to add minus, as the concentration is not at all decreasing. It is increasing. This is about our average rate. This is about first one. First way to represent the rate, that is average rate. By this manner, we'll represent our average rate. Then the second one is instantaneous rate. Instantaneous rate. The basic difference between average rate and instantaneous rate is, here we are considering after some time intervals or else after some concentration interval gaps. We are considering the rate of concentration after, let's see here, 2 intervals of time. This is our average rate. If we calculate the rate of reaction with respect to 2 time intervals, in between 2 time intervals, then that is average rate. But if we are calculating the rate of reaction at a particular time interval, here no particular time, no interval will be here. So let's take at this time interval, at this time. If we want to calculate the rate at a particular time, then that sort of a rate of reaction is known as instantaneous rate of a reaction. If a rate of a reaction is calculated at a particular time, not in time interval gap, then that sort of a reaction is known as rate is known as instantaneous rate. At that time, the delta T tends to 0. Delta T tends to 0. Change in time interval is 0 here, because we are choosing or we are opting only one particular time, but not time interval, but not change in time we are considering. So obviously delta T is equal to tends to 0. Then what about the rate, average rate of reaction? Same thing, delta C by delta T. But here delta T tends to 0 here. Limit application will be there when we consider instantaneous rate. Limitation is there, that is delta T tends to 0. So here, instead of writing like this, we can write, instead of using delta, we can use small d, dc by dt. If at all we are using delta, means time change, change in interval. Delta C means change in interval of concentration. Delta T means change in interval of with respect to time. But here we are using d, dc by dt. This is instantaneous rate, as we are not at all using intervals. We are choosing the rate, we are calculating the rate at a particular time, but not in between the time interval, then that will be instantaneous rate.